Okay, guys, I'm going to try my best, but my voice sounds really bad. But we're going to go through lesson 5 for today. So we're going to analyze graphs of polynomial functions. And just at the top, I've just got a couple different graphs for us to look at. And we haven't talked about this at all yet. We have what's called a relative maximum and a relative minimum. So you guys can see these on the graph. And then underneath here, absolute maximum, absolute minimum. We'll talk about that in a second. But if you look at this polynomial here I have graphed, minimum degree here would be 3. And what I've got going on, because this graph goes up to positive infinity and down to negative infinity, there's not an absolute maximum or minimum because I'm going towards infinity. We do have what they call a relative maximum or relative minimum, which basically occurs at the top. It almost looks like the vertex of a parabola, but like in this range here, this is called a relative maximum, that highest point there. This is called a relative minimum, that lowest point there. And they just talk about the y value of that point when they're asking for the relative maximum or minimum. All right, over here, we kind of highlight the graph so we can see it a little bit better. This is minimum, a 4th degree polynomial. Okay, now, because the end behavior here both points down, there's what they call no absolute minimum because it goes to negative infinity. It doesn't go to a specific value. But on this graph, you have relative minimum. It's kind of like the bottom of where the graph turns there. You have a relative maximum, which you'll notice this point is lower than this point. So relative minimum here, relative maximum. And the absolute maximum, this can occur if you have an even function. This is absolutely the top of the graph. There's no points above this because the graph doesn't point up. And so you can have an absolute maximum or you can have an absolute minimum. We'll talk about that on some of the graphs as we go through this today. But just as a little reminder, absolute maximum does not ever exist if the greatest y value of the entire graph does not exist if your end behavior, first of all, it can only exist if it's even. So it's not going to exist if you have an odd function, but it's not going to exist if both ends point up. And an absolute minimum, like this one that we just looked at here, doesn't have an absolute minimum. That's not going to exist if the graph points down because it goes to infinity. All right, and then it just says here, they don't exist for odd degree polynomials because one end goes up forever, one end goes down forever. So both ends of the graph, one of them goes to positive infinity, one of them goes to negative infinity. So absolute mins or maxes will not ever exist for an odd function, but they can exist for an even function. Okay, so I'm just going to scooch this up a little bit. And we're just going to talk about domain, range, relative max, relative min, absolute max, and absolute min for this graph. Okay, so the domain, all right, this goes down, but it goes to the left forever. This goes up, but it goes to the right forever. So it should just be negative infinity to infinity. And that should be the case for all of these graphs we're going to look at. Now the range, that could be different depending on the graph. This end goes down to negative infinity. This end goes up to positive infinity. So the range here will actually be the same. And that should be true for any odd function that you have, or odd degree polynomial, let me say it that way. All right, now your relative max occurs at a turning point, like the top part of a turning point. So right here, I'm just going to write down that y value. And I got these graphs kind of snipped from Desmos, so that's why they've got some really specific points there for you. The relative minimum is going to occur at this turning point, kind of the bottom of what almost looks like a parabola there. And I just need to write down the y coordinate there. Absolute max, absolute min does not happen if you have an odd degree polynomial, so none for this graph. And I maybe should have added this in here. A lot of the questions ask you for the y-intercept. You can see it right there on the graph. That's the 0, negative 30 there. And if you don't have a point snapped on the graph like I do here, anytime you want a y-intercept, if you have the equation, which I don't actually have it here, but you can just set x equal to 0 if you don't have a graph where you can see where it crosses. Okay, now this is at the bottom of the page, but it's literally the same graph. And so actually, we're going to do intervals of increasing, decreasing, positive, negative. Let me just do something real quick. I'm going to do these on two separate graphs so I can color them differently. But if you remember from our quadratics unit, increasing, decreasing, you're literally just tracing the graph. So just from left to right, here, this portion of the graph would be increasing because I'm drawing up on that. And then, excuse me, when I get to this relative maximum here, then I turn and I start decreasing. And then I get to this relative minimum, turn, and that part is increasing again. If you guys remember when we did this with quadratics, this is based on these points where the graph turns. All right, so I'm just going to put negative infinity and positive infinity because we're going to go across the x-axis when we identify this. And so right here, I'm using the x values for this. This is like negative 3.667. And that would be an interval where I'm increasing. Then from that point, I start decreasing. And I stop decreasing when I get down here, which is going to correspond, this is just an x value of 1. And then the rest of the graph there is increasing. So I'm going to have 3 different intervals. Let me see if I can scooch this up and try and get it on the page. Okay, so I am increasing from negative infinity until I get to this x value, this negative 3.667. And I have another increasing interval. If you guys remember, you just put a little union symbol. It means both of these intervals are increasing. And these are all parentheses. I start increasing again at the x value of 1. And then as I go to the right forever to positive infinity, the rest of the graph is increasing. Now, the portion of the graph that's decreasing is just right here from that negative 3.667 to 1. And I don't think I can get that on the screen with the graph at the same time, but I'm going to go ahead and scooch this up and write just one interval decreasing there. These are always x values. And this just goes from negative 3.667 to 1. And I'm just using those numbers from the graph. These are always describing parts of the domain. So you want to use x values, excuse me, and that's true for the positive and negative intervals, which we're going to do on the graph at the bottom of the page here. Okay, so I just scooched down to the bottom graph. All right, now, intervals of positive and negative. Positive is where you are above the x-axis, and negative is where you are below the x-axis. So these are going to occur at the 0. So if you're above the x-axis where your y values are positive, then that's considered a positive portion of the graph. If you are below the x-axis where your y values are negative, that is considered a negative interval on the graph. So these are going to switch over at the 0. So right where I touch the x-axis here, and again, we're using x values, so negative infinity. So this first piece, that would be negative. So my entire graph is all below the x-axis until I get to negative 5 right here. And so let me just list that as I go. So that piece is negative, from negative infinity to negative 5. Now at negative 5, we hop above the x-axis, and I stay above the x-axis till I get to negative 2. So that would be up here, this would be positive. Excuse me. So that interval from negative 5 to negative 2. Okay, then I dip back below the x-axis, so I'm negative here, from negative 2 all the way until I get to the 3. So from negative 2 to 3, all those y values are negative as we're going across from left to right. And then the rest of the graph, after I get to 3, hops back above the x-axis. And so as I travel to the right forever, from 3 to infinity for all those x values, the rest of the graph is going to be positive. Okay, flipped over to the back, a little different graph to analyze. All right, again, domain here, this is going up and up, but it's going left forever and right forever. So the domain for all of these should be negative infinity to infinity. Now, if we have an even function, which we do here, both the ends point up, then we should have a range that is not negative infinity to infinity. So if I approach from the bottom of the graph, I'm not touching any part of the graph till I get to this point right here. And make sure for your range, you want to use your y values for that. So the lowest point on the graph, oops, sorry, let me go ahead. I'm going to need to use a bracket there because I have an actual point there, that negative 45.335. And then the rest of the graph goes up forever. So the rest of the graph would go to positive infinity. And so I should have a bracket that doesn't look really good on there and a parenthesis always on your infinities. Now, relative maximum here, this is kind of tricky, but these are at turning points. So my relative maximum here actually is right at that turning point. That is a relative maximum, and it's actually the y value I'm using here, which is 0. Your relative minimum, I'm going to write that in there, relative max. Your relative minimum on this is going to be right here. And I just want the y value, so negative 6.353. And then you're like, why didn't I use this one? Well, this is absolutely the bottom point on the graph. Everything else goes above that. So that is an absolute minimum, that negative 45.335. I don't have an absolute maximum because this points up to positive infinity on this graph. So I have an absolute minimum, but not an absolute maximum for this graph. It's one or the other. You're not going to have both. Okay, now let's do increasing, decreasing, positive, and negative for this. So I'm going to go ahead and do increasing, decreasing just on the graph as I've got it here. So here, decreasing, decreasing. And then these two pieces, this is increasing. The rest of the graph is increasing. These are going to switch over at those turning points. So on the graph here, I think I'm switching between increasing and decreasing here, and switching between increasing and decreasing here. So I'm going to see if I can get this on the screen at the same time, and I don't think I'm going to be able to do that. Okay, so I'm just going to describe it here real quick. This first interval, from negative infinity until I get to this point, I'm using the x values for this, negative 1.386, I am decreasing. So I'm going to just scooch this up so you guys can see this on the screen. Maybe. All right, so from negative infinity to negative 1.386, that little piece I colored in purple, that is decreasing. Okay, now if you look back at the graph, the next little piece is increasing. So starting at that same value, negative 1.386, I am increasing until I get to the origin right there, which has an x value of 0. So I'm going to put that on the increasing line here. So negative 1.386, and until I get to 0. And I'm going to pull this back down so you can see. Now at 0, on that x value, then I start decreasing until I get to the x value here of 2.886. So I'm back in the decreasing portion of this. Sorry for flipping back and forth. But from 0 until I get to the x value 2.886, that portion of the graph, I colored it in purple, that's decreasing. Now, the rest of the graph, once I turn here, this is my absolute minimum here. Once the graph turns that final time, the rest of the graph points up forever. And so that's going to go to positive infinity. But remember, I'm not going up, I'm traveling to the right. So I'm describing what I'm doing from left to right. So as I go from that 2.886 to infinity, the rest of that graph is increasing. So I'm going to scooch this back up. And this is going to be 2.886 to positive infinity. The rest of that graph is increasing. Okay, and then we can do positive and negative right on this graph here. Just wanted to use different graphs for coloring. So I am positive anywhere I am above the x-axis. And this one's kind of tricky. There's a bounce on this, and you have to write a bounce as a separate interval if it touches the x-axis. So we're going to talk about that on this question. So positive and negative is going to switch over at the zeros. So all the way to the left forever, this part of the graph is above the x-axis, so that's considered positive. So from negative infinity until I touch this point right here, which has an x value of -2, that's one of my zeros. All right, then I'm negative here, and that goes from -2 till I come back and touch the x-axis again at the origin. Now, I know I colored the rest of this all kind of my green highlighter, and it's all below the x-axis, but because you come back and touch to bounce here, you do have to write these as separate intervals. So from -2 to 0, I am negative, but at those 2 points, I am not considered positive or negative because I'm actually touching the x-axis. So that's why I'm going to write this as a separate interval. Now, this interval, right, I'm going down, all this has got negative y values, so it's just going to be from 0 until I come back up and get to the 4. These are always x values. And then after I hit 4, the rest of the graph is pointed up forever, so all those y values are positive. So I'm traveling to the right, so once I hit 4, as I go to the right forever, this graph is going up forever, so it's going up to positive infinity. So that would be my interval.